Consider the linear transformation T defined from Rnx to Rn plus 1x by given structure. And what about T? T is 1 1 and on 2. Option B, T is 1 1 but not on 2. Option C, T is on 2 but not 1 1. And option D, T is neither 1 1 nor on 2. Means we have to check this linear transformation is 1 1 or on 2 in all these four options. As dimension of domain of this linear transformation is n plus 1 and dimension of codomain will be n plus 2. So matrix representation of this linear transformation have the size n plus 2 cross n plus 1. This will be the size of matrix representation if we need to check that this linear transformation is 1 1 or on 2. So we need to check nullity or rank of this one. So for nullity, I define we consider a px belongs to null of t. If this belongs to null of t, then according to the definition of null space of t, we have t of px will be integration from 0 to x pt dt. And this one we can apply Leibniz rule of integration. Sorry, according what will be this? 0 to x pt dt equals to 0. This integral is going to 0 means integral of 0 function as an integrand function of 0 function is only 0. Otherwise, if we have any integrand function, then value of value of this integral will be some number, because of using integral we find area. So area will be either 0 or some positive value. So it is clearly understood that t of 0 as a 0 polynomial will be 0. So nullity of this linear transformation is 0. It means t is 1 1. In other words, you can find matrix representation of this. Nullity is 0, so you can apply rank nullity theorem. Rank will be n plus 1. Rank is n plus 1. This is not same as n plus 2 as a dimension of codomain. So this is not onto. So t is 1 1 but not onto. Option B is correct. But matrix representation t 0, we know that 0 of domain will go to 0 of codomain. So t0 is 0, and basis elements are for polynomials of degree at most n will be 1 comma x square plus x cube and so on up to x raised to the power n. So first basis element is t1 and image of this is x, then tx image of x square will be x cube, and what we have the structure of the matrix representation of this linear transformation is as 0 1, because of this is row for 1 1 x square and so on up to x raised to the power n plus 1. So 0 1 0 0 0, then 0 0 1 0 0, then 0 0 0 1 0 0, and finally we will have 0 0 0 and 0. This will be entire 0 column, or not a 0 column. You will get lower diagonal. You will get a lower diagonal as a 1 1. So how many non-zero entry? How many non-zero entry as 1 2 3? Only one row is empty or one column is 0. So n plus 1 will be the rank of this matrix representation. If I say matrix representation is A, then rank of A will be n plus 1. Rank is n plus 1. So by nullity nullity of this linear transformation will be 0. So using this concept you can also find which one correct option.